Okay guys, we are moving on to compound probability today of independent events, okay? So compound probability means you have two events that have occurred, okay? For instance, you roll a dice or roll a die twice. You try to draw a red Skittle out of a bag of Skittles like 3 times. So 3 things are happening, basically. You're finding 2 or more outcomes, okay? So an independent event versus a dependent event. So independent event means that the outcome of the first does not affect the outcome of the second, okay? An example of that would be if I were drawing a marble out of a bag. I would draw the first marble out and then I would replace it, and then I would draw the second marble. If I didn't replace it, that would affect the total number of marbles there are, the total number of outcomes, the sample space, okay? So if I replace it, that makes it an independent event because one event does not depend on the other, okay? Now, if I didn't replace it, that would become a dependent event, which we will talk about for the next class, okay? All right, so basically what you do is you calculate the probability of each event. Then you multiply the fractions. And you multiply the fractions because, again, you write the probability ratio as a fraction, okay? So, first example is, what is the probability of rolling an odd number, then rolling a 2 using a 6-sided die? Okay, well, we find the probability of each thing. So the odd numbers. Okay, 6-sided die means there are 3 odd numbers, 1, 3, and 5. Okay, so odd is going to be 3 out of 6. Okay, and then times a 2, probability of rolling a 2 is 1 out of 6. Okay, so if I multiply them together, remember when you're multiplying fractions, you multiply the tops, the numerators, and then you multiply the bottoms, the denominators. So the numerators, 3 times 1 is 3, 6 times 6 is 36. If I wanted to simplify that, that would be 1/12, I think. Yeah, 1/12. You don't have to simplify it, but you can. Okay. So again, you find the probability of each thing and you multiply them together. Okay. The second example is a bag contains 6 red, 4 purple, and 2 blue marbles. What is the probability of drawing a blue, then a purple with replacement? That's important after the first drawing. So if it doesn't say with replacement, then that's dependent, and that you don't know how to do that yet, but I'm not going to give you a problem with that, obviously. So with replacement means it is an independent event, okay? So it says, what is the probability of drawing a blue? So blue is, probability of blue is, oh, we haven't done this yet. So there are 6 red, 4 purple, and 2 blue. Well, we don't know the sample space because we have to add those numbers together, right? If there's 6 red plus 4 purple is 10. 10 plus 2 is 12. So some of these you'll have to calculate the sample space or the total number of outcomes. So the sample space, which you learned that word yesterday, is 12, and that's, remember, the total number of outcomes. So because it doesn't give you that here, you're going to have to add them together, okay? Let me actually just add that. So 6 plus 4 plus 2 equals 12. Okay, now let's go back to the problem. All right, so it's going to be over 12. All right, first one is blue. Okay, that there. So the probability of blue, there are 2 blue, 2 out of 12. Okay, and then the second one is a purple. There are 4 purple, so purple would be 4 out of 12. Okay. Then I multiply them together. 2 times 4 is 8. 12 times 12 is 144. Okay. You can simplify that, but you don't have to. Let's see here. You could simplify it by dividing by 4. And that would leave me with 2, and then 4 goes into 14, 3 times 3, 36, 2 over 36, or 1 over 18. Okay, but again, you can keep it as that, or this. Okay, The next video we will go over dependent events, but that's all for today.